I know we're getting late on time, so I'll just burn through this really quick. I have the slides up on speaker deck. They're probably also at the GreatConf YouTube and maybe on the Gradle Summit. We've open sourced a whole bunch of our internal Gradle plugins. So our internal custom build that everybody internally uses a lot of these open source pieces. And hopefully they're useful to other people, both so that we can get contributions and that your use of Gradle can be better. We have a Twitter account, Nebula Plugins, if you want to see what we release. Most of them are up on the our GitHub page. Nebula Plugins is the org. And then we'll skip through all of this stuff. We release on Travis. We just tag the repo, and it goes out via all kinds of automation that Ben talked about. Like if you're going to be doing plugin publishing, you're going to want to set all that up. All right. So one of the first ones that we put out was Nebula Test. So this is going to help you do integration testing until you can switch all your stuff to TestKit. We're in the process of doing that for a lot of our plugins. So the changes that I just made to our publishing plugin use TestKit under the hood instead of Nebula Test. We create a whole bunch of helper specs. So plugin project spec is going to try to apply your plugin to a multi-project, a single project, do a couple other things to just exercise it. We have an integration spec, which works very similar to just calling the test kit. You can set up a build file, run various tasks, check on the results. So this was switching to test kit was really easy here. The build results object that we return is basically what test kit's returning. So not a whole lot to change for was a task executed, was it up to date, what's the standard output or the standard error contain. One thing that we'll probably keep using Nebula Tests, at least for a little bit for, is dependency generation. So we have some plugins that do various things with dependencies. And so instead of trying to find something out in the wild that fulfills our requirements for exercising various things, we have something that'll just build a whole tree of dependencies so that we can exercise it, build the exact tree that we need to show the problems. So we have a builder pattern. It'll go and generate a whole Ivy or Maven repo that you can test against. We have a Nebula core, which is just a series of a couple of tasks and helpers for other methods. So a download and unzip and untar, and then some various other things like detecting if you're the top level project, if you're a sub project, things like that for some of our plugins that do various things based on where they're applied in the tree. We have a project plugin. This is really intended for like internal builds. So every build at Netflix is going to, under the hood, apply Nebula Project plugin. It's going to do things like you will publish a Java doc in the source jar. We're going to put some info into your Ivy file that you generate, or a Maven file, as the case may be. And then set up some contacts, add various facets. So instead of having to set up like a whole integration test or a functional test, you can just say, I would like just an integ test source set, and it's going to wire all of the configurations and create the sources and the tests for you. We also recommend creating project plugins for various things. So we have a Netflix OSS project plugin. So all of our open source projects that are Java-based apply this. Creates various release processes, configures publishing, makes sure that Apache licenses are on the things in the right place. Do a little helpful error handling. So like Javadoc and JDK 8 became way more picky. So let's go and hide that for the OSS people. We have an OS package plugin, so if you want to, instead of having to write an RPM spec file or a Debian control file, you can just use OS package to quickly generate this. So you have an OS package block, you can have all of those files, install, pre-install, post-install, uninstall. It works really similar to a copy spec, so take the root directory in my project and put it under / when it gets to the end system. We create build RPMs and build debs that you can have special settings based on what you need. So maybe a library is called one thing on Debian and another thing on CentOS. We have a slightly more opinionated one, Nebula OS Package plugin. This will do some things like set up daemon tools or automatically take something that already has the application plugin applied to it and copy it in the right way. Dependency lock plugin. So a lot of our internal builds want to use dynamic dependencies. We really like them too, so they keep getting updated. We also want to have repeatable builds. So if we just let the build have the dynamic versions like this, they come back a month later with a bug, they're going to get new versions of Groovy, new versions of Guava, and it'll be really hard to reproduce. So we have a task to generate lock and save lock, and that's going to output a JSON file, which we'll then use when we're doing our builds. So we recommend most of our teams to have nightly or more frequent builds to generate a lock file for the day, so they have that consistent known state and time to resolve against. We can also have it include transitives. So it's going to give a little bit more information. Where did this transitively come from? Some of our internal builds have 750, 800 dependencies, so it can be very useful for those teams to have that known file of here were my dependencies yesterday, here are my dependencies today. One of those 10 things that changed has broken me. So which teams do I track down to ask why they did this to me? We have an extra configurations plugin. If you've ever wanted to have provided libraries in just a standard jar, that's available. And we do optional dependencies with that syntax. We released a publishing plugin. This is basically removing some of the boilerplate from using the new Maven-publish or Ivy-publish. So these tasks are going to create a task that's going to generate that jar, add it to the artifacts, do things like that. Then we have this whole series of things. So make sure my POM has the Apache license in it, add various values and informational things to my POM. Dependencies is going to go through and detect if you're a Java or a war project and put the right things in there. If you're a war project, it's actually going to add the dependencies to the POM or the Ivy file so that you have a nice reference to go against. So like internally, we don't expect people to depend against a war, but we want those Ivy or POM files to go and do some other insight with some of our other tools. We have a resolved plugin, which is going to, if you happen to have a dynamic dependency, it is going to go and put an actual resolved number in the POM or the Ivy file, so you don't have that dynamic version to resolve against later. Yeah, and we have the same kind of thing for Ivy. It's kind of small, but that's some of the kind of information that we add to our Maven files. So things like what was the JDK that was built on, what's the hash that this was built with, was it Jenkins, was it Travis, things like that. We have a metrics plugin out there. This was so yeah, we've seen what Gradle has announced with Gradle.com, looking forward to using that. This was kind of a first cut to kind of expose some of those information. So we have something out there that'll upload to Elasticache build times and various information about the build so that we can find out what tasks people are using how long their builds are taking, see if anything we're doing is making builds take longer. We have an override plugin. This basically lets you, on the command line, go and change anything about your build. So there are many teams here who would rather quickly go to their Jenkins job and add a property to go and trigger, or to change something about their build rather than modify their build.gradle. So we have the override dot whatever the property is in your build.gradle, and it'll change the values. So we can change source compatibility or some custom thing that we wrote. We have a blacklist plugin. So there are multiple problematic dependencies out in the wild. So there's different ways to handle it. So we have a translate function, which we probably don't need anymore with the new changes in Gradle, where you can set, Google Collections is now Guava and things like that. And then we also have the ability to completely fail builds based on various things. So if you want to get something like Spring 256 or Jersey Bundle out of your dependency graph, you can just block it, and that'll fail anybody who has a direct dependency on it. And then we have a whole series of other plugins. Dependency Recommender basically lets teams produce a BOM. So say a team deep in your stack or one at the edge can say, these are the recommended versions of all these libraries, where teams in the middle might be like, I want to use Guava, but I don't care what version. And then if you look at our GitHub page, we have all of those other things. All right, that was nice and quick because we're running out of time. Questions? All right. Okay, do we have any other interesting plugins in the pipeline? Nothing right now. I have some dreams of some things that will be nice, like auto-detecting if your API changes, so you bump the right semver thing, stuff like that. Well, we have one that's, we're doing another, we don't know how much we'll develop this blacklist plugin. We have another one that we're going to do for some various other internal problems that we have.
Those plugins are great. Thank you guys for sharing.
Okay. Yes?
During the development.
Wow. Did we use internal APIs? One, so yes, many times. What would we ask to be exposed?
You could have more than one if you need.
So I can't think of one off the top of my head because we've been good at haranguing Ben, who's our on-site consultant, every once in a while to expose those. So like if you've been following any of our open source Nebula plugin stuff, we were stuck on 2.2 for a long time because our publishing plugin was using all kinds of internal publishing bits, and it doesn't do that anymore because that was annoying to change. So it's wherever possible, we are trying to use non-internal bits from now on. Okay, when we build RPMs or devs, do we reason about them as dependencies in other projects? No, we don't. We put a require statement on there and let the underlying operating system do what it is supposed to do. So some of our internal packages will require another one of our internal packages, and then we're hoping that Debian or CentOS does the right thing to resolve that. Okay. If we have a project that depends on another one in the OS level, do we auto-generate the requires? So we don't have any builds that do that. Most of our multi-project builds are designed around, I have like a common jar, a client jar, and a war. And the war is what gets packaged into the Debian. So most of the time, we don't have that level. Most projects depend on each other at the client jar level rather than OS level. All right, thank you very much.